So when we were solving trig equations, just like any other type of equation that I see, for example, 3x equals 6, if I asked you to solve this, I'm hoping you say x must be 2. Wow, that's amazing. And that's exactly what we're doing today, except we're not solving a simple equation as above, we are solving a trig equation. So there's a few different kind of pointers that we're going to look at. The first thing is we're going to determine what quadrants my angles are in using the cast rule. So what quadrants using cast? Now, from last time, we said that our cast rule helped us to develop or helped us to say what ratios were positive. Okay, so that says everything is positive here versus sine positive in quadrant 2. The second thing we do is we figure out what is the reference angle, and then we look to see if there are 2 or possibly more values. That comes from the last part. If we need to add or subtract 360. Okay, this is only sometimes. We check in the question to see when we have to do that or when we don't have to do that. Just make that full screen. Okay, so here's the first question that we're going to do. When is the sine of theta equal to root 3 over 2? Well, I'm just going to quickly draw out our basic unit circle, 30, 45, 60. And remember, this is all of my values are over 2. And I start at the top, root 1, root 2, root 3, root 3, root 2, square root of 1, which is positive 1. So that's at 60, 45, and 30. Recalling from last class that my coordinates go cosine, comma, sine. If you can't remember, it's always alphabetical. So for what value is sine root 3 over 2? Hopefully I see it's 60 degrees. Root 3 over 2. This is my sine value. So theta is equal to 60 degrees. You have one solution. You're the best. I now need to look. I'm like, okay, in this case, cosine is positive. I see that. Well, where else using cast is it positive? It should be positive in this quadrant. So if I were to create that same triangle with a reference angle of 60, I can solve for my other possible angle, 180 minus 60 degrees. So I'm left with 2 possible solutions. Theta could be 60 or theta could be 120. Both of those angles give me the same ratio and they give me that same value, positive or negative, in this case negative sign. So it's all about finding those reference angles using my quadrants. So this question should be pretty familiar from last time. Question 2 is a little more challenging because it's tangent. Right. From last class we said that tangent is the ratio of sine over cosine. So if I'm told that my tangent ratio is -1, what do I know about sine and cosine? One of them is definitely negative, that's true. And they must both also be the same value. Think of 3 divided by 3 is +1. So where on my unit circle is my sine and cosine the same? Yeah, at my 45s. Okay, 45 increments give me that positive value. Now I want it to be negative, so I think about my cast rule. If tangent is negative here and here. So my reference, this would be 45, and this would also be 45 degrees. To get my first angle, we'll make it green here. We'll say theta would be 180 minus 45. So I get my first angle. That's nice. And then I'd have to go all the way around from start to finish to get my second angle. This would be 360 subtract 45. There are my two solutions. Now I always want to look back to the original equation and look, it said it was only interested between 0 and 360 degrees. That's perfect. That's all I've answered. I've only looked within the first circle. But there is a scenario where we may have to look over. But the best part is the method is the exact same for solving. So I'm evaluating different thetas for different ratios. Let's take a look at question 2. This is different A because this looks like a mess. But I can fix that mess by rewriting it and moving my numbers to one side. Remember, I want to get sine theta by itself. So I would take that -1 and move it over. I'm just shifting the 1 over to the other side of my equation. Just like isolating for x, I'm isolating for sine of theta. What would my next step be to get theta, sine of theta on its own?
Divide through by root 2.
You got it. Divide through by root 2. Now, remember, yeah, this is the same as if I were to say sine of theta equals root 2 over 2. That's not necessary. You could have left it the line above, but in my unit circle it shows up like that. So maybe I'm going to just remember that and go right to root 2 over 2, or I go through that step. It doesn't matter. So when does this happen? Well, we just said that happens at the 45s. Woo, 45 degrees. But I know I want my sine to be positive. So I'm looking here and here to find my other reference angle. Okay. 80 minus 45, which gives me 135. So woohoo! Those are my two solutions. 1, 2.
But Miss Palmer, you forgot something.
Oh, I forgot something. Why, thank you. That was a great intro. It said don't stop looking. Look all the way to 720. That's 2 circles. So that's me saying, here's a quadrant, go around once, but just kidding, go around again. I'm doing the same thing, I'm just going further and further. So the easiest thing to do is I can add 360 degrees to both of these values. When I do that, I end up at the exact same place, but just a circle further in. So that gives me those 2 more values. Okay. See you later. Okay. 405, not 409, pardon. And 495. So now I have totally completed the question because I looked in the domain. If I'm not sure if I have to keep going, I just do a test value. If I added 360 onto this, I'm going to go over the 720 cap. So I'm done. There are 4 places on the unit circle where this value is true. Okay. So right now you are pros, and all we're doing is we're going to take this concept and turn it a little bit more into quadratics. So when you're ready, you can flip your page. I think everyone is on the same page, literally and physically. And I'm asking you to solve for this. It's a little different, mostly because it's the sine of 2x, not just regular x. The very first thing I want to do is I want to get rid of that 2x. So I'm going to say let theta represent 2x, which means I'm able to rewrite my equation. Oh, sine of theta equals -1. That's much nicer. That makes sense to me. If I were to look at my unit circle, think of my points 0, 1, 0, -1. I want this point when sine is -1, which means that my theta, so it would be 270. If it was 90, it would be +1. So I get 270, that's great. But I wasn't concerned about theta. I was concerned about x. So I am substituting in my 2x. And I just divide. The entire theta is 270, but each x value is 135. I look back at the question, and it says I only had to look at 360, so I can stop. That's the only place on my unit circle where my sign is -1. And I'm done. I don't even have to round because it's already in the nearest degree.
So, why does it round to the nearest degree? Is to trick you?
This probably is just I might have switched the question or I might have kept that. I generally wouldn't write that if it is a degree. I'll generally say at the beginning round to the nearest degree, and that just carries through. Yeah. Okay. Now this one, although it looks scary, what does a scary face look like? Do you think I can find a scary? Oh, scary doesn't start with a C. Scary. Ah, no, I want surprised. Ha!
To the Kermit the Frog one.
No, do you guys know who that is?
Oh, is that from?
Oh, I broke him. Oh, there he is. He's fixed. He's used to be a TV show I used to watch after schools when I was growing up, and I forget his name. But he's a student, and he's freaking out right now. But don't freak out. Don't be like him. Okay, make yourself smile, because this, although looks frightening, can really be turned into something quite nice. The first thing that you need to see, though, or recognize, and this is probably something a little new, is this notation. Sine. It's sine squared theta, and it's the sine of theta all squared. It's the same thing as sine theta times sine theta.
Then why is this squared?
Why is it squared there? Because if it were here, it would look like it was the sine of theta squared. So we avoid that mistake by putting the squared on the sign. Okay. With that in mind, I'm going to write a let statement. Let x represent the scary stuff, which is, in this case, sine of theta. Yeah, this question becomes so nice. 2x squared minus 7x plus 3 equals 0. You got it. So grade 10 math is coming back to us. I look to factor. I can't common factor that 2 out. So we say what multiplies to positive 6 adds to -7, -6, -1. Remember, I split my middle term up. 2x squared minus 6x minus x plus 3. And I common factor those two terms. I'm left with an x minus 3 and a 2x minus 1. And we're just going to pause so that everyone kind of gets back on the same page. Oh, I wish I could remember the name of that show. It'll come to me, though.
Full House.
No, it's not Full House, but I love that show, too. Okay, it doesn't matter. Okay, if I wanted to solve, you could either substitute in your theta or your sine theta now, but I would encourage you to isolate first. Here are my options, x equals 3 or x equals 1/2. But I know that I'm not dealing with just x. I'm dealing with sine of theta is 3.
Do 1 over 2. Because it only 60 degrees. No, that's wrong. Sorry.
30.
30 degrees.
You got it.
Because I was thinking of the sine.
So we're going to go with the second one, just because that's maybe what was a little more natural. When does this happen? That happens at 30 degrees. But please remember my cast rule. Sine is positive here as well as here. So it's also at 150 degrees. In terms of my sine theta equals 3 on the left-hand side, my unit circle is only 1 unit in each direction, which means my values can never be greater than 1. 3 definitely is greater than 1. There are no solutions here. If you took to, your calculator to solve, if you maybe weren't thinking, you'll get error. Okay? But really what I'm looking for is that no solutions. There is an error, but I want to know what that means. It means there's no value that satisfies that. And look, it only wants between 0 and 360. so I don't have to work any harder. Okay. Topanga is his girlfriend's name. For those of you that are listening later, I'm sure that you know. Oh, yeah? Boy Meets World.
Yeah.
Thank you.
Oh, that show. That's so old.
I know it's old.
That's mean.
It's awesome.
There's nothing wrong with being old. You forgot.
Don't imply things.
Isn't there one called Girl Meets World? I just said it was mean.
Pardon?
There's one called Girl Meets World as well.
Yeah, I think they tried to
never
remake it.
watched
I feel like it was maybe a bit of a miss, but I'm not
I've
sure.
never watched
You
it.
guys are pros right now. You just made it to the dum 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 challenge section.
So this is the part where we do test if we're smart or
Yeah, well, this is the part where you get to maybe work a little bit harder to have that same result in the end. It's kind of a little bit of critical thinking, more of a thinking question. This question relies on a little bit of information, which we're going to see all of next class. Next class is all about something called identities. Identities are rules in math that are really helpful when solving equations. This is the one that we're going to talk about right now. This says sine squared theta plus cos squared theta of whatever angle I choose in the whole wide world, it's always going to equal 1. It's just kind of a cool fun fact. The reason being is because think about my sine and cosine values always being switched in my unit circle, right, for different places. They will always add up to 1 when I square them. So just kind of a fun fact.
But is it sine? So does it have to be sine?
Squared
Squared
and
theta.
cos there, squared, exactly. So trig identities are identities that you are not expected to necessarily derive or be able to memorize, but they're for you to be able to utilize. How can I use this to make my life helpful? If I look at this question, first I think it kind of looks similar to the last one, but notice that I have a cos and I have a sine. Yuck. Okay. First I'm just going to take this equation and I'm going to rewrite it just so it's in the same kind of dimension as I'd like it there. And because I don't want to have two different terms, it's like having x's and y's to factor, that doesn't help. So I'm going to see this and I want to replace it. I'm going to replace it with an identity. If I look above, I could rearrange that equation to be 1 minus sine squared theta. In rearranging that equation, I can now use it to substitute.
Can we let like sine theta or x represent sine theta?
We're going to do that as well, and I'm going to do that in a different step, but you're so right. So this becomes, 1 minus sine squared theta, and I'm just keeping everything else the same. Now, I encourage you to expand this before doing any let x represent values, and I just decided to make that orange for no reason. When I expand, I'm left with 6 minus 6 sine squared theta minus sine theta minus 5. And then the very last thing I can do is I can see that I have two terms that I could combine, the 5 and the 6. This is the last step of simplification that I have to do. You do not have to show all of these steps, but you can, feel free. I generally do, because it can get complex. This looks a lot nicer. So this is where I write my let statement. Let's switch to pink. Let x represent sine of theta. Now you do not have to do that. You can just go right into factoring that. It's up to you. It's just generally you're a little more comfortable with this expression rather than the expression above. So I look to see what multiplies to negative 6, adds to negative 1.
Negative 3 and 2.
You got it, negative 3 and 2. Breaking it into my components, 6x squared minus 3x plus 2x plus 1. I common factor out of my first two terms, a 3x, 2x plus 1, pardon. And I have my very final step. Again, as you go through to solve this, I like solving first. Negative a half and positive 1/3. Because for me that makes sense. The issue is, or what I encourage you to focus on, is not forgetting that you're not done. Because it's tempting to be like, look, I have 2 answers. I'm the best. And then you turn the page. But don't. Because I'm not talking about x. I'm talking about sine of theta. And I really need to solve for those values.
Ms. Palmer,
You got
would
it.
be x equal negative 1/3 because
The negative would go over, but negative divided by negative 3 would be positive.
Oh yeah, the symbol for 3 doesn't change.
Yeah. Okay. So here are my 2 options. If I look back to my unit circle, 1/2 sine is at 30 degrees, but it's negative.
And it'll be the 2 bottom
Yeah.
ones.
So think here. So my reference angle is 30 degrees. So my first angle, yeah, it would be 180 plus 30, so 210 or 330 degrees. What about 1/3? Is 1/3 on my unit circle?
Nope.
No, it's not. It's a weird value. If I'm looking to solve, I have to use my calculator. This is not a special triangle.
Actually, it's gonna be Palmer number 2.
Yeah, so I get 19.5 degrees. What is tempting, especially with this example, is you get 19.5 and then you really think you're done. But remember, sine is positive not only here, but also there. So the very last one would be 180 minus 19.5 to give us 160.5. So there are
Number 2.
1, 2, yes, calculator, 3, 4. So remember, this is not,
It's not supposed to be number 2. It's supposed to be.
oh, yes, thank you.
Yeah, that's what I was.
Yep. Sorry, I didn't realize that. I accidentally wrote a 1/2 instead of a 1/3. Not on the unit circle.
But even though it's not on the unit circle, we still have to solve.
I can still solve, it's just there's no exact answer. That's
So
all.
would you ask us to solve for this circle? Like on a
Yeah,
test, if we
for
did
sure.
it,
Yeah.
If we didn't solve for it, we would have lost marks.
Yeah, you gotta solve for it because it's less than 1. Remember, if it's bigger than 1, there's no solution. Okay. So not only did you guys get through all of that, you also did the challenge question, and you did it without even a grumble, which is wonderful. Now, 14 and 15, these are the exact same things as the challenge from above. Your goal in class today is, as you're going through it, completing about 14 questions. There's more than that assigned, but that's kind of what you're looking for. I'm going to put the handout up on the board, and it starts out, it's just about solving. When are those values? What are those values for?
You want us to